Why stock market prediction? Stock market prediction is highly challenging as the market is highly stochastic and most models only predict from historical prices and model that of a time series problem. Is there more we can do to improve performance and give further insights on how the stock market moves? What kind of information do we need? And where should we collect the data from? Oh yes, news headlines. But can we really predict stock trends with news? According to many research papers, media sentiment is an important predictor of daily news stock returns. An increase in optimistic news predicts a short-run increase in stock returns, and conversely, pessimistic news is associated with a temporary decrease in stock returns. With that in mind, we will use machine learning to predict stock trends using news sentiments. Firstly, we will extract the sentiment score from news headlines. We will be using NLTK's Valence-Aware Dictionary for sentiment reasoning, also known as VADA. VADA is a pre-trained model that relies on a dictionary that maps lexical features to emotion intensities. And with VADA, we are able to extract the sentiment score from any given sentence. Here is an example of how VADA runs lexicon on its pre-processed data to return a negative sentiment of the following news headline due to the presence of the negative word fell. Next, we will pick a machine learning model to predict the next day rise and fall based on the sentiment scores as inputs. After trying a bunch of models, we arrived at the following results. However, we noticed that the accuracy scores were still relatively low, with the highest at 58.6% using the random forest model. One of the main reasons for the poor performance is the curse of dimensionality, as we are working with high-dimensional data. Due to the large number of features, we run the risk of massively overfitting our model, which will result in terrible performance. In addition, as high dimensionality causes data observations to appear equidistant from one another, this results in difficulty in clustering. We can counter this problem, however, by using principal component analysis, which reduces the dimensionality of large data sets whilst maintaining most of the information in the reduced set. This is done by extracting features based on variance. After running PCA on our data and retesting them on the various models, we managed to get a high accuracy of 80.3% from XGBoost. Lastly, we found that we can also counter the curse of dimensionality by using a linear discriminant analysis, which results in a higher accuracy of 81.2%. In conclusion, we were able to achieve an 81.2% accuracy when using news sentiments to predict stock prices. With an interpretable model that can make predictions of stock movements from news headlines, we are now able to better predict the stock market. Thank you.